This isn't the Galapagos Islands. And that's not Charles Darwin. It's a disused council tip in Bolton, and these are primary school children following in his footsteps.
This way.
Why don't you got a map out?
St Stephen's and All Martyrs Primary School in Bolton has had huge success introducing Charles Darwin's work as an explorer and naturalist into the curriculum.
What else would you be doing to find out what sort of species are out there?
The Following in the Footsteps of Darwin project, a child-centred, inquiry-based programme, won the 2007 Rolls-Royce Science Prize and £16,000 towards science education.
The children are extremely enthusiastic, excited about doing real hands-on natural science. It's been fantastic for them.
The project will provide you with some ideas for engaging with outside agencies and for developing practical outdoor learning activities. It shows how you can boost children's enthusiasm for science and the work of Charles Darwin. Children build skills as enquirers and thinkers.
Because who was Charles Darwin?
I think Charles Darwin was like an explorer.
An explorer.
He sort of had a theory that we were related to apes.
Right, and we developed from them apes. Okay.
He was a man who went to the Galapagos Islands.
So he's an explorer who went to the Galapagos Islands. Thank you very much. How do you think he was feeling? He was on a journey. You could have been scared.
Excited and like not knowing what to find there.
Inquisitive, is that a good word to use?
Yeah.
He probably would have been anxious.
Do you think he would be like worried because you don't know what's going to happen?
Most definitely he would have been worried he didn't know what was going to happen. And when you go into the unknown, there's always that element of worry, isn't there? There's an element of excitement and motivation, but you're also a little bit worried. We're now going to follow in Charles Darwin's footsteps to collect the flora and fauna from Bradford Park.
Colin Walton is using Charles Darwin's adventures and the classification work that led to his theory of evolution as a hook for his Year 6 children.
What does classifying of insects or of plants mean?
You could say what parts the plant has, like petal, the stem, the roots, and what it needs to grow and stuff.
And how many they have?
Yeah.
The children work with a botanist from Bolton Museum, who's brought in a plant collection Darwin himself would have been proud of.
I'm going to show you the oldest specimens in the museum, older than any of the animals, any of the insects, the plants, and there's only 10 of them, and these are collected almost 300 years ago. So these are really, really old, really precious.
Pupils will be making comparisons between these historic samples and those they'll be collecting for themselves.
Do you think we'll find it today? It looks too old, doesn't it? I don't know though. I don't think we will. No.
I'm going to jump forward to about 150 years ago when Thomas Greenlees was born. And he was born in Bolton, so he was a local man. This was published in 1920, and it's a list of all the plants in Bolton, and it's a really good start for a study is to look at this book.
Bolton botanist Thomas Greenlees collected samples from a site right next to the school, the same site the children will be investigating themselves, but not with ancient old equipment like this.
That's your field press, sheets of cardboard, sheets of blotting paper. And the blotting paper takes the moisture out, that's what it does. It dries it out, keeps it flat and preserves it. So, shall we look at some of the plants themselves now? It says on this the 10th of July, it's 1937. But these are the ones from Bradford Park that I brought today. This project with the school has been great. It's a perfect setting, it's right on the doorstep of where this collection is from. And it's a marvellous opportunity to look at the past using the specimens and looking at now.
Now, it's really important when you're looking at these plants, you think about when you go down in the field, are any of these plants still there? It's it.
Exploring on your doorstep is just as interesting for these children as it is for Darwin to go to the Galapagos Islands and find out what he found, even though it's just round the corner. It's just as amazing and just as exciting.
Let's look where we are. And where's your random sample that you're going to go to?
We're seeing that we should go there. It's exciting because I know we're going to be like digging and stuff, and I like digging. We have to go through there.
Go to the river and then follow the river up for like like 20, 50 steps and then go up.
And then like...
Feels like you're reading Charles Darwin and trying to find new stuff. This way.
The samples collected will be compared with last year's data from the same area.
Could it be an elm?
Elm, yeah.
I think it could be either an elm or
a birch. Or
that's the others. Where's the others?
Joe!
Joe!
Joe, what do you think this is?
We've decided that this leaf is either birch, elm or beech. Which one do you think? Looks more like a beech. Yeah, that's what we thought, right.
Over time, the project will build a database of species diversity to allow children to track changes in flora and fauna.
What is it? Amelia, where's the baby ash? Baby ash.
Yeah.
This plant, it's still got a very few flowers on the top, but these are the seed pods. They do smell very much of garlic, don't they?
Random sampling is an important technique when carrying out field research.
Good place because it's like loads of different plants. And it's like different creatures.
How should we get that? Wait, you can hear a bird.
What have you found?
A spider. I got a spider off the tree. We found a spider's web. There's loads of them.
What's that you've got, young man?
A bistort.
A bistar.
And you can cook it in the spring. It makes a pudding.
GPS technology means they'll know precisely where to come back next time.
Peter, locate this spot on the GPS so that when people come next year, they'll be able to find out where we've dug and then compare the differences in the area.
Darwin would have given his eye teeth for one of these. Time to discuss what they've all observed and collected.
Baby millipede.
So far,
look what we just found under a rock.
Excitement is running high.
Outdoor education is vital to enthuse the children, to make it that's real, they're getting involved and really enthusing them to want to investigate further. I think it's vital that we get outside and they explore their local environment and really get to know what things are out there for them to do.
Snail.
Snail, got it.
Slug. Got. Red-headed centipede.
We found a hawthorn, an oak, a bramble.
Do you think that they were there 100 years ago?
Some of them look pretty old, but I don't say it's 100 years old.
We got this massive purple bug and we don't know what it's called.
How will you be able to classify what it is?
Colour.
Colour?
Legs.
How many legs does it have? The shape of its body?
Like round at the back and then it's like smaller for its head.
Learning about classification was designed to help boost understanding of Darwin's methods.
How does it feel being outdoors, being real explorers, following Charles Darwin's footsteps, as opposed to being in the classroom?
Instead of staying inside and listening to the teacher talk, it sort of makes it easier to learn for us by experiencing how it looks like and what it feels like. Have you seen all these leaves?
The project developed out of the head teacher's concerns that the school could do more to develop its science curriculum.
Initially we did a survey throughout the school of children's feelings about the curriculum, and one of the worrying things for us was when we did that, science was quite low down on the list of their favourites. It seemed an ideal opportunity then to raise the profile of science through the school, and of course you can't deny the benefits of the finances as well.
The Rolls-Royce Science Prize was judged after schools submitted videos describing their projects and tracking progress. St Stephen's entry was led by a very active school governor.
I did all the videoing for the actual project, and so the kids have a record of everything that they've done. The teachers have a record of what they've done for next year so they can repeat it, and everybody can actually see what's gone on and show that what the kids are getting out of it all the way through.
You really need somebody to take a lead in a project as big as this. We're a small school, there's only 7, 8 teaching staff. If you have somebody to lead the project, somebody to liaise with the outside agencies and the different organisations that are involved, it obviously makes it far more effective, and that's what Robert was able to do as a governor. He was able to do that.
Robert Moores got the University of Bolton involved in the project, so primary school children experience laboratories and learning in a higher education context. A significant achievement for a school the size of St Stephen's. Samples collected from Bradford Park are brought to the labs, where technician Alan Crawshaw leads the learning. Tolgren funnels are used to drive out the insects from the soil samples. It's a degree-level activity.
The animals that are in that soil don't like heat and light, like it dark. They move away from that through the soil and they come out at the mesh at the bottom there and into the alcohol in the bottom.
What does alcohol do to that? Kills them. The thing.
Well, it kills them and it preserves them. It stops them from rotting, basically. And then we just put them in a petri dish and look under the microscope, see what we've got. Now, what can you see there?
Oh, what's that?
Woodlice.
So woodlice, fly.
Another activity was an experiment to identify the habitat that woodlice prefer: dark, light, wet or dry. It's a complex behavioural matrix, but one which the children were well able to cope with.
They're doing a runner.
If only the woodlice would behave themselves.
I think it's important to get primary school children in and engage them with science. Let them ask questions. Tell them there's no such thing as a stupid question. Darwin, this is what he did. He looked at something and he asked questions. And this is how you get the answers. Oh, it's fantastic. Yeah, fantastic.
It is dead.
It was great, because I've learnt that woodlice like living in the dark.
I learned that there were 2 different types of woodlice. I only thought there were one type.
I didn't know that if you kept insects inside alcohol, then they wouldn't shrivel up as bad.
Back in class, there's more observational science, and the making of accurate records of what's been seen and collected is stressed.
Well, I decided to sketch so it'd help me with my sorting diagram and how I could identify the leaves.
Can you give us an example of what you've got?
Has it got a smooth edge? Is it thin/narrow? For that leaf, because it was quite thin, it was a rowan, and if it wasn't, it would have been a bramble or an oak.
And I believe you found an insect that you weren't quite sure what it was.
We went on the computers and found out that it was a wireworm.
A wireworm. What characteristics does the insect have, Cameron, that you could identify through that microscope?
On its head, it's got like 2 small little tentacles. You can tell it's like a dark orangey colour.
There's a rich learning experience for the budding explorers.
Birch, elm or...
By maximising its opportunities locally, tapping into the resources that a school governor can create, and using the methods and approach of Charles Darwin, the school is aiming to provide a grounding for the more detailed studies about evolution at secondary school.
We saw 30 children really engaged with scientific principles, and it was a taste of Darwinism. We didn't go into a lot of detail about evolution, but what the children then take with them to year 7, 8 and 9, we've sparked an interest in science that I think some of them will keep for quite some time.
What's it feel like to be scientists?
Really?